Hello, everyone, and welcome to my class. Uh, please get out your notebooks and pencils, and I'll start screen sharing. Hold on. Say yes if you in the chat if you can see my screen. If you can't, say no. Yes, very good. Okay, so today we will be continuing our unit on Euclidean geometry. So we will start by reviewing. All right. So we're gonna review the equation of a circle, and then we're gonna add some more to that. We're going to learn about how to write the equation of the top half of the circle and the bottom half of the circle, and the right and left half of the circle. All right, we're gonna derive those formulas. Okay, so let's review the equation of a circle. Can anybody tell me what you must have to graph a circle? What do you need to graph a circle? How do you make a circle? Does anybody remember this from last lecture? What do you need to graph a circle? Okay, what do you need? Yes, center. You have to have the coordinates of the center and the radius. All right, Reza and Carney, you don't know. Okay, well, we are reviewing, so hopefully you'll get the idea soon. So, the equation of circle, we need the radius, the length of the radius, and the coordinates of the center, right? Okay, so we have a coordinate plane, and we have our center. Our center HK, and then we're going to have a circle. Sure, that's a very bad circle, but don't judge. Okay, so that's our circle, and point P here is on the circle. Okay, so this is C, and we have point P here on the circle. Hold on, let me make it a little bit clearer. More clear. Okay. So, and the distance between C and P, that is the radius. All right. So we're going to have an equation of the circle, which must include the center and the radius. So how are we going to do that? Okay, so basically that is just going to be the distance between C and P. All right. So the distance formula, who knows what the distance formula is? Does anybody know what the distance formula between 2 points is? Yes, you forgot about this, Father. Basically, Pythagorean theorem, right? Yes, Pythagorean theorem. So, it is going to be the square root of x 2 minus x1 squared plus y2 minus y1 squared. Okay, that is the distance formula. So, what we need to do here is to find the distance between CP. That would equal to the square root of x minus k squared and what is it? Plus y minus h squared, which equals r. Okay, and we don't like square roots, so we're going to get rid of that we're just going to have x minus k squared plus y minus h squared equals r squared. All right. So that is our equation of the circle. Okay. That is our equation of the circle. So are there any questions on this? Any questions? Oh, wait. Hold on. I mixed it up. And it's x minus h. Okay, there we go. Now are there any questions? Okay, yes. No questions, no questions. Okay. So let's do some examples. So we need to graph the circle x minus 2 squared plus y plus 3 squared equals 16. All right. Well, you can't graph on Zoom, so we are going to find the radius and the center of our circle. Okay. Once we have those, we can graph, right? So please put the radius and the center of the circle in the chat. Right. I'll give you a few moments to do that, and I'll check back in a few moments. Okay, so are there any answers? Any answers? The center is 2, -3, and r is equal to 4. Very good, very good. So, how are we going to find this? So, we take this and this. Okay, that will be our center, right? So our center is going to be 2, -3. Now, a common mistake when you're doing this is you think it's going to be -2, 3, all right? Now, that's not going to be correct because, see, the formula here is going to be the radius, the center is hk, right? So if you have a negative, if you had a negative number as h, then it would be plus h. All right. If you had a negative number as k, it would be y plus k. So when you see this plus sign right here, this indicates that 3 is negative. And if you see a negative, then negative sign here, then 2 is positive. Okay. And our radius would just be the square root of 16, which equals 4. All right. So now we can graph our circle. Let's graph our circle. Okay, and all right. It seems to be under the x-axis. Okay, so 1, 2, hold on. 1, 2, and then 1, 2, 3. All right, so now we have to graph. Now we have our radius. 1, 2, 3, 4. Okay, that's correct. You have to go 1, 2, 3, 4 down as well. 1, 2, 3, 4. Okay. So 1, 2, 3. Okay, so you have this, and this. Okay, so Now we can kind of create our circle. Right, that's a rough drawing of our circle. And this is how you graph a circle using our center and our radius. All right, are there any questions? Any questions on this? If there are no questions, now move on. Okay, so now we need to find the center and the radius of the circle graphed by x squared plus y squared plus 4y minus 117 equals 0. How do we do this? I'll give you a few moments to try and solve this problem, and then we'll check it. All right, we have one answer. The center is 0, -2, and the radius is 11. Very good, very good. Okay, so what we need to do here is we need to use complete squares. Okay, we have to complete the square. So you need to move the -117 to the other side first. It's being very troublesome. Okay. We have x squared plus y squared plus 4y equals 117. Now, you need to add something more. That's going to be 4 because you want to complete this square, right? So now you have x squared plus y plus 2 squared equals 121. Okay? So then you have our equation of the circle, meaning that the radius is going to be the square root of 121, which is 11. And the center is going to be 0, -2. Okay, are there any questions on this? Are there any questions? If there are no questions, we'll start learning new material for today. So no questions. Okay. Let's learn about the top half of a circle. Okay, how do you find the top half of a circle? Are there any thoughts on it? How we're going to define the top half of our circle here? Any thoughts? Okay, I'll give you a moment to brainstorm about things. How are we going to define the top half of our circle? Okay, so the top half of our circle, let me draw this real quick. Hold on, let me use a different color. Right, this is our top half of the circle. Okay. we still have the center HK, and we still have point P, X, Y. All right. So how are we going to denote the top half of our circle? So we have center HK right here, point P, X, Y. So what is true about Y right here? Because we're focusing on Y because the X stays the same. The X stays the same. Okay. But the Y changes. Okay. What is true about Y in the top half of a circle? What is true? What is true about the relation between Y and K? Okay. What is true about that? Great. Yes. Y is larger than K, meaning that Y minus K is greater than or equal to 0. Okay? Y minus K is greater than or equal to 0. So now we can kind of derive a formula on that. Okay, so this is our solution. So please write this down. This is very important. A point that is on the top half of a circle has the property y is greater than or equal to k. All right. So now we can look at our formula here. So previously we had x minus h squared plus y minus k squared equals r squared, right? So what we need to do is we need to focus on y, right? So let's move the x to the other side. All right, let's square root. Now what do we get? Does anybody know what is the square root of y minus k squared? What is the square root of y minus k squared? What is that? It's not y minus k. What is the square root of y minus k squared? Does anybody know what is the square root of y minus k? Positive y minus k. Guess you could say that. Yes, absolute value. Great. Absolute value of y minus k. All right, you need to know this in Algebra 2 and analytic geometry, okay? The square root of x squared equals the square root, the absolute value of x, all right? This is about principal square root, all right? That is why the square root of 4 is equal to 2, because it takes the absolute value of the square root, that is the principal square root. And this can be very helpful in a lot of ways, okay? Now don't be confused with this. The square root of x squared. Now that's just x. But the square root of x squared, that is absolute value of x, all right? This is very important. Okay. So with that in mind, we can say that y minus k, the absolute value of y minus k equals the square root of r squared minus x minus h squared, all right? That is what we can say about this. Now, since we know that y minus k is greater than or equal to 0, what does that imply? Since we know that, then that means that the absolute value of y minus k equals what? What does that mean? All right. So think back about absolute value. Okay, think back about absolute value. Let me write it over here. So the absolute value of x equals, all right, the absolute value of x equals just x if x is greater than or equal to 0. But it equals negative x if x is less than or equal to 0, all right? That is the absolute value. Okay, that is the definition of absolute value. Since y minus k is greater than 0, then that means that the absolute value of y minus k is going to be just y minus k because it's positive, right? It's just y minus k. Now from this, you can see that y, okay, hold on. See that y equals k plus the square root of r squared minus x minus h squared. Now this is the equation of the top half of the circle, all right? This is the top half of the circle. Okay. So are there any questions on this property? Any questions? Yes, we can get rid of the absolute value bars. Okay. The absolute value bars. Now, how do we get, I don't think you were blank, whatever your username is. I don't think you were here for my lecture about principal square root and absolute value, or just number theory in general. You can get rid of the bars of an absolute value, all right? Get rid of the bars of an absolute value. Okay. So let me give an example about this theorem, okay? So let's say the absolute value of 5, okay? Since x is positive, then that's just 5, right? Now what about negative 5? Negative 5, what is it? It's negative x if x is less than 0. Now, negative 5 is less than 0, right? Meaning it's negative 5, which equals to 5. Okay, so that is why this works. So you can definitely get rid of the bars of the absolute value. All right. So now let's brainstorm things about the bottom half of the circle. Think back about what I told you, what I taught you earlier. Okay, last slide. What did I teach you last slide? Think back about that. How are we going to find the bottom half of a circle? Okay, how do we find the bottom half of a circle? All right, brainstorm things about the bottom half of a circle in the chat. How are we going to define the bottom half of a circle? Okay, so we have this circle here. Now we are going to define its bottom half, its lower half, all right? Okay, what is true about the bottom half of a circle? All right, what is its relation between y and k? What is its relation? All right. So what did we say about the relation between y and k in the top half of the circle? Well, y is greater than k. Now, if we're talking about the bottom half of the circle, how are we going to do that? What the heck? Hold on. Yes. Okay, so about the bottom half of the circle, we can say that y is less than k. Okay, so y is less than k. This is very important. Y minus k is less than, or nope, less than or equal to 0. So now we can derive our formula. So our formula here, solution. So a point on the bottom half of a circle has the property y is less than or equal to k. All right. So let's derive our formula. Now let's go back to here. Y minus k, absolute value of y minus k equals the square root of r squared minus x minus h squared. All right. But now when we remove the absolute value bars, how are we going to do this? All right, think back to here. Think back. The absolute value of x is negative x if x is less than or equal to 0. And y minus k is less than or equal to 0. Meaning that once we remove the absolute value bars, then it's going to be negative y minus k. Okay, yeah. Which is basically k minus y. Right, so we have k minus y here, which equals the square root of r squared minus x minus h squared. All right, from that we can derive that we get k minus square root of r squared minus x minus h squared. All right, that is how we get it. Are there any questions on this? Any questions? Yes. So this time it is y minus k is less than or equal to 0. Now I'm going to save you some time and not derive the formulas of the right half and the left half, all right? Because we all know how to do this now, right? Now it's the relationship between x and h. For example, in the right half, then x is greater than or equal to h. If it's the left half, then x is less than or equal to h. So with this information, you can derive the left and right half of a circle by itself. Okay? So are there any questions on this? Any questions? If there are no questions, then I will continue. So we need to sketch the graph of y equals 3 minus the square root of negative x squared minus 2x. How are we going to do this? Okay, how are we going to do this? What we need to do is we need since we need to complete the square, right? Because we don't have a radius right now, right? We don't look like we have a radius because it's the square root of r squared minus x minus h squared, all right? And this, can anybody tell me what this is? This is the equation of the bottom half of a circle. Now first, before we need to do anything, we need to complete this formula. All right. Basically, what we need to do is we need to add 1 to complete the square, right? But how do we how do we complete the square? We can just add 1, right? You can't just add 1. If you have to add 1, you have to take it off again because we can't affect the value of the equation. So what we need to do is we need to add 1 and then subtract 1. All right, so let's look at what this is. Okay, this thing. We should remove the negative sign, right? It's negative x squared plus 2x. Okay? So if we add 1 here and minus 1 here, basically be equal to 1 minus x squared. Oh wait, never mind. What we need to do, what is this? Okay, we need to, hold on. We need, let's not add the parentheses first. Should be easier to see that way. Okay, so, oh yes, it is 1 minus, yeah. Okay, so, now that, what we need to do now is going to be equal to 1 minus x plus 1 squared. Okay, so we have 1 minus x plus 1 squared, and now we know what our center and what our radius is. So our radius would just be 1 square root of 1, right? So radius 1. Now the center is a little bit tricky. Not that tricky. You just have to subtract 3 from y, right? So it's just 3. Okay, so it's going to be y minus 3 squared. So normally the circle here, normally what would the circle be here? Normally the circle would be x plus 1 squared plus y minus 3 squared equals 1, right? So you can see here that the center of this of the circle would be negative 1, 3. Okay, so now we know how to sketch this graph. So let's sketch it here. We have negative 1, 1, 2, 3. Okay, and we have our very small circle. It's just the radius is only 1. Okay. And we know that this circle, it's only going to be the bottom half. Okay, it's only going to be the bottom half. So it's the bottom half of the circle. All right, so that is how you sketch this graph. Are there any questions? Any specific questions about this? Applications of half circle, yeah. See, your applications of half circle, that's what we, applications of half circles. Well, you can do a lot of things with half circles. Okay, you can use the equations of half circles when you're learning about functions, which are very useful. You can use it to solve half circles. You can kind of use it to solve a lot of real life problems. Yes, so it's always pretty useful to know half circles and equations of real circles, because circles, we use a lot of circles in real life as well. So now I really haven't used any circles in real life yet, but hopefully, well, not really hopefully, when you get older, usually, let's say you had a building, right? You had a building, and you have to find like this perimeter on one side of it. I guess that's how you use half circles. I really don't know as well. Yes, I know you're literally the same age as me. You should be answering questions, Edward. Even I know this. Okay, so Introduction to lines and slope, yeah. So you might think that lines and slope are very, you already learned about it, right? But we're going a little deeper into lines and slope, all right? I'm gonna give you a small review on lines and slope, okay? Hopefully we won't stay in this for very long. We should not stay in this for very long. In fact, I don't like lines at all. It's just very boring, but lines and slope are very useful, right? Now, let's learn about a little bit about lines, okay? A little bit about lines, okay? So, what is the definition of a line? Okay, what is the definition of a line? Okay, any line is determined by 2 points on the coordinate plane such that any other point on the line which is going to be pxy, is okay, such that any other point on the line is going to be it's going to have the same slope, right? And it's so hold on, this is hard to explain in words, so let's just leave it at this right now. It's determined by 2 points on the coordinate line. Okay, so now let me draw a diagram for you first. Okay, so let's say we have 2 points, right? Those are our 2 points that determine our line here. Okay, so we have PQ, P and Q. We have PQ. We have P and Q here, all right? So now we have another point on our line, right? On the line, okay? Of course, these extend. Lines extend forever. And of course, I have to erase Q now because I did that. Okay, Q is over here. So we have another point on our line, R, right? It's in the middle of everything. Okay, we have another point, R. Okay, now R is XY. Okay, let's call this point R now. Because PQ is easier to do. So Q, what's that going to be? That's going to be X2, Y2. All right, and then we're going to have P as X1, Y1, Y1, okay? All right, so we're going to have this point R on our line if and only if, all right? This is if and only if Y minus Y1 over X minus X1, which equals Y2 minus Y1 over X2 minus X1. All right, so the slope of P to R should be equal to P to Q. All right, so the slope is constant on a line, and we call that slope M. All right, we call that slope M. So now with that, we can derive a few formulas. on how to graph a line. So this is called the point slope line, the point slope formula. And I want you to always use this formula whenever you're giving a point, okay, in the slope, all right? Because this is the easiest way, and it's the most direct way to graph a line, all right? This is the most important, very important way. Okay, don't start with like slope-intercept form or like general form, okay? That's a bit harder to do. So let's start with point slope form as always, because you just need a point and a slope. All right. Or you can just have 2 points. All right. 2 points, you can get a slope and another point. All right. So what is the point slope form? Well, you see here, basically, you're going to take that, you're going to take y minus y1 over x minus x1, and you're going to make a formula, right? So from this, you know that y minus y1 over x minus x1 equals to m, right? So you can just cross multiply. Hold on. Yes. So this is our slope and the point slope form, right? It requires the least amount of information. And now we have another formula we can get here. We can have slope intercept form. And that's mainly about the y-intercept, okay? Let's say if you change this a little bit, just change it a little bit, you can get y equals mx plus b. All right. So how would we graph this? We have a slope here, and we have the slope intercept form. I mean the slope intercept. I mean hold on, the y-intercept. Okay, we have the y-intercept, and we can use the slope to find another point, and bam, you have a line. Okay. And then sometimes problems want you to have a general form, which is ax plus by equals c, right? You understand after I'll give you this example. So let's go over an example. Let's try to clear up your understanding. Okay, so, well, most of you know these formulas already, so it shouldn't be that big of a problem. So, number 1, find the equation of line L, which passes through P 2, -5, and Q 3, 4 in slope intercept form in general form, all right? So I'll give you a few moments to do this, and I'll be back in a few moments. All right, so are there any questions, or are there any answers? Any answers, okay. Okay. From one point to another point, yes, it is a set of points that stretch infinitely in both directions. Yes, that is correct as well. And okay, so all right, so we have a problem here, don't we? So yeah, well, you did get it correct, kind of. Yes, you did get it correct. So the slope-intercept form would be y equals 9x minus 23, and then you can also derive the general form after that. So what we need to do here is we need to find the slope first, right? We need to find the slope. we're giving 2 points. Bam, slope. Okay, so it's going to be y1, y2 minus y1. So choose one to be your y2 and stick with it, basically. 4 plus 5 over 3 minus 2 equals 9. All right. So this would be your y2, y1, x2, x1. So you just basically subtract them, right? So now you get 9. So now you are given 2 points as well. Okay, so you just choose one and stick with it. I'm going to choose 2, -5. Y minus -5 equals 9 times x minus 2. You just plug it into the formula, the point slope form. Okay, then you get y plus 5 equals 9x minus 18. Okay, you get what? Y equals 9x minus 23. All right, so this is the slope-intercept form. Okay, so this is one solution. Now the other solution we need is the general form, right? The general form. Okay, so what else do we need? We need to find the general form. Well, that's basically ax plus by equals c, right? So you just move the terms a little bit, okay, and you get what you want. It's going to be 9x minus y equals 23. I accidentally wrote 33. 23. Okay, so those will be our two solutions. Okay, so those are our two solutions. Are there any questions? Any questions? If there are no questions, then we will end this class early once again because I don't like lines. Probably neither do you. So it is quite an easy because you have learned about lines before. It's just more in depth. Okay. So without further ado, let's end our class because I want to go watch YouTube. Okay. So yes. Bye, people. Bye. I'll see you in like 1 week. Sure, sad, isn't it? So, okay. If you have any questions, sorry to say this, but I don't care.